Good morning. We are on adding and subtracting fractions with unlike denominators on page 114. Before I get into this concept development, I want to make sure that we remember what we are doing as far as subtraction, period. There are certain principles we have to keep in mind whenever we are subtracting. So again, we are adding and subtracting fractions with unlike denominators, but today focusing on subtraction of them. Okay, so I've just taken some notes before we begin, and I'm going to go over these with you so maybe you'll have a better understanding of why we do things like we do. But let's go back to regular subtraction. Students, I don't know, they kind of sort of have a tendency to want to forget this idea that you must always subtract from the top number to the bottom number. Students sometimes want to take the easy route with this number, 4,000 minus 761. They'll say 1 minus 0 is 1. No. You must always subtract from the top to the bottom. And if your number is not large enough, it is going to be your responsibility to make it larger by regrouping, renaming. So let's just do this basic problem. If you'll look at the first column is 0 minus 1. Well, if I have nothing there, what am I going to have to do? I'm going to have to go next door, but there's nothing there. Then I have to go next door to it, nothing there, until there's finally a whole number. So really, we're looking at 400, and he's needing to borrow a set of 10. Well, right now there's 400 sets of 10, and if he gives one away, that's why these two zeros become 9, and this 4 becomes a 3, because 1 away from 400 is 399. So we're going to add this 10 to a 0, which makes it 10. Now, some teachers will have you mark that out and make it a 10, but I just say it's easier just to go ahead and add it with it. That's just a small 10. Okay, and then I can do my subtraction. 10 minus from top to bottom. Where? Top to the bottom. So you subtract this way. All right, so 10 minus 1 will be 9. 9 minus 6 is 3. 9 minus 7 is 2. And 3 minus nothing is 3. So we're going to keep this in mind with subtraction with fractions. Now we're going to talk about subtracting fractions with unlike denominators. So this problem is one that's in your book. So we're going to do it on pencil paper, obviously first, and then we're going to look at maybe a little drawing that goes with it that's in your book on page 114. So this problem has 3 and 3/6 minus 1 2/3. Well, immediately, this is what we should be thinking. Alert, alert. There are unlike denominators. If they need attention, if these denominators are not alike, this goes with any type of adding or subtracting fractions, you're going to have to find a least common multiple, which is also called the least common denominator, because you're using the least common multiple with fractions, and the denominator is the down number, the bottom number in a fraction. So what we're going to do for that then is we're going to recopy the problem, and then we are going to, and always we stack them if they don't have like denominators. We just put them in workable form. So then I'm going to bring the whole numbers over. That's the first step. And you may want to be taking notes on this or watch it one time through and then go back and take notes on it. So bring your whole numbers over. And then you start thinking about, well, I have thirds and I have sixes. Here's just a thought. To decide the least common denominator, if I can count by the smaller denominator, which is 3, if I can skip count, and I'm going to write that word right above it, skip count. If I can skip count by 3s and land on 6, what is 3? What's the next multiple of 3? 6. There you go. That is your least common denominator. So it says right here, if I can skip count by the smaller denominator and land on the other larger denominator, I can use it the 6 of the larger numerator, that should be denominator. I should use the other denominator. Okay, I should use the other denominator. I can use it as my least common denominator. Okay, I'm so glad I'm reading this and thinking. Okay, decide the least common denominator. If I can skip count by the smaller denominator and land on the other larger denominator, I can use it as my least common denominator. So I'm going to be using 6. So if this is already in 6, then all I have to do is just bring this over. So I really did not do anything to rename it. But now, if this is thirds, I am going to have to do, what did I do to the 3 to give it 6 parts? Well, I definitely increased it. We know what we did was we multiplied it by 2, because 3 times 2 is 6. Then we're going to do the same thing to my numerator, and 2 times 2 is 4. Now, we've got a new fraction, new mixed number minus a new mixed number with like denominators. So I'm just going to copy that again right down here, keeping everything neat and aligned. That is one of your most important things when you have mixed numbers, is keeping everything neat and tidy. All right, so here's your concept. My numerator. This is your next little thought right here. My numerator in the top fraction, is it large enough? 3 minus 4. Because once you have the denominators are like, you just leave those alone until, they just are still going to be 6s. So when you look at your numerators and you're subtracting 3 minus 4, that's not large enough. So what I'm going to have to do, I must regroup, just like we did with zeros in the problem a few minutes ago. We went next door and regrouped. Boy, I'm having fun with these pens. Okay, so since it's not enough, this little fraction, he hops over the wall into the whole numberville land, and the whole number, it says, hey, can I help you? And that little numerator up top, he says, I need some help. And he says, what can I do for you? And he says, I need to borrow something, and I need to borrow some money, or some fractional part, whatever. And he says, well, I am a whole number, as you know, but if you go back over to the fractional side, you must do as the fractions do. So he says, okay, I promise I will have him do that. So then he says, 3 says, okay, I'm going to rename myself as a 2 and 6 6. I can let you have a 6 6 because we know that 6 6 is the same thing as a whole, right? So the 6 6 says, I can let you have my whole, but when you go back over, you are still a 6 6, but you must add to the 3 6, which is already there. And he says, okay, so y'all are now compatible and y'all can work together as a team. And so the 6 6, he jumps back over the fence with the 3 6 and he says, okay, 3 6 6 plus 3 6, I'm adding these two numbers together, becomes 9 6. The whole number is now a 2. It's just renaming, and that's how you rename, regroup with fractions. Minus 1 and 4 6, subtract from the top to the bottom. Finally large enough, 9 minus 4 is 5. 6, 2 minus 1 is 1. Okay, so now we are good to go with that. Again, I'm going to go back over this and say, because I could not subtract 3 minus 4, I had to go, the 3 6 had to go next door and say, can I borrow 1? And the 3 says, okay, yes, I will change myself into a 2 and 6 6. But when the 6 6 goes over, you guys must be compatible with each other and go together, come together as a team. So 6 6 adds with 3 6, and that makes the 9 6. So this number and this number add together, and that's what you're adding the numerator. 6 plus 3 is 9, and the denominator's there. All right, whole number's over, and then you can carry out your subtraction. I hope that helps some. I kind of sort of like the story. I may not say it exactly, you know, with my old people, but the concept works. Okay, so now what we're going to do is we're going to look at this same problem. We know the answer to this problem was 1 and 5 6, right? So is it the same when you can do this picture? Okay, so the first thing when this one says when you don't have, notice what they did. The number sentence is going across, but why did they stack these numbers? Because they're unlike denominators and you're setting them up so that you can get like denominators. We are using sixes. We saw how we did that. So here's your drawing of 3 and 3 6 right here. Then it says the regrouping is required, so you're going to rename 3 as 2 plus 1 or 2 and 6 6. Did we just do that? Did we just do that? Yes, we did. Okay, and then we're going to add the 2 and 6 6 plus the 3. Why? The 6 6, remember? Said if you're going back over to the fraction view, you have to get along and work together as a team. And so that ended up being 2 and 9 6. Then you're going to subtract. Let's look at the picture of this. So they took away, or actually what they did was they renamed the one whole, which is what we had, to 6 6. Okay? All right, so then you had the 6 6 and the 3 6, which made all together 1 2 3 4 5 6 7 8 9 sixes. Okay? Then the bottom picture actually shows the taking away or the subtracting of 1 and 2/3, or which is the same thing as 1 and 4 6. So you're going to mark out the one whole, and then the 4 6, they're just going from the end of it and taking it away, so that, and that was 4 6 marked off, so that this would be together with this. How much do we see for our final answer or difference? 1 and 1 2 3 4 5 6. Okay, so now what we're going to do is we are going to work 2 problems below, and we'll go ahead and take a look at these together. I'm going to zoom in so we'll have some space. We're going to do this right here on this paper. The first one, do we have like denominators? No. So what do we have to do? We have to find the least common denominator. The first step is to say, can you count by the least denominator, which is a 4, and land on the other denominator, which is an 8? Well, 4, 8. Yeah, I mean, there you go. That's the very first multiple they have in common. So that's why we're going to use eighths. Remember, whole numbers come over to begin with. And then we're going to rename both of these to eighths. Well, this one is already in eighths. 4 times what is 8? 4 times 2, that makes it have 8 parts. Do the same thing to the numerator. 3 times 2 is 6. Now we're going to see if we can subtract 3 minus 6. No, it is not large enough. So then what are we going to do? We're going to go 3/8 hops over and he says, hey, may I borrow 1? And he says, yes, but when you do, I'm going to let my one whole become an 8/8. And 8/8 and 3/8 must work together as a team. And they said, oh, okay, we promise, we will. So 8/8 adds with 3/8 and become a larger team of 11/8. And the 4 remains the same. You're bringing over the other fraction or mixed number, 2 and 6/8. And now we're going to actually do our subtraction. 11 minus 6 is 5 over 8. And 4 minus 2 is 2. I hope this is helping. All right, let's look at the next one. So, zoom in on this. There we go. All right, so what are we going to do for this one? We're going to bring our whole numbers over. I cannot subtract 2. I can't, alert, because I don't have like denominators. So can I skip count by 5s and land on 10? 5, 10, yes. So we're going to use tenths as our least common multiple, aka least common denominator. This is already in tenths. It's going to remain at 1 7/10. What did I do to the 5 to get 10 parts? Times 2. 2 times 2 is 4. Now, do not subtract 7 minus 4. You always subtract from the top to the bottom. Okay, my little story is 4/10 hops over to whole numberville, and he says, may I borrow one? He says, sure, but you have to become a 10/10, and you have to work together. So 4/10 says, okay, 10/10, let's go. So we've got 1 and 10/10. The 10/10 says, I'm going to hop back over. Wee! He hops over, and he and 4/10 become 14/10. The whole number, which was 1, stays. 1 and 7/10. We're going to subtract. 14 minus 7 is 7/10, and 1 minus nothing is nothing. All right, I know you've got this. You can do it. So we're going to get some practice in just a little bit with it.